torque on a current carrying loop. Determine the net torque on the loop shown. So what do we have here? We've got current that's going around this loop of 3 amps. The loop has the dimensions 1 meter in that direction, 2 meters in that direction, and we have a uniform magnetic field of 6 Teslas pointing towards the right. This top portion here, those two portions, there's going to be no magnetic force there, is there? Because the current will be parallel or anti-parallel to the magnetic field, so there's no force on those two portions. Same thing with this portion down at the bottom. There will be no magnetic force, but there will be a magnetic force on this left portion of the loop as well as the right portion of the loop. Let's look at the left portion of the loop first. And what we want to find is we want to find the torque. Torque, you might remember from mechanics, it's R cross F. Well, if we find the magnitude of that, it's R F sine theta. Well, here, theta is going to be 90 degrees, and so the sine of that is just 1, so that's nice. We're going to be spinning this about a central axis that goes right down here, which means that the R value is going to be 1/2 of a meter, 0.5 meters. Now, what's the force? With what force are we pushing on this leftmost wire? Well, that's going to be the magnetic force on that length of wire, which is ILB. When everything's perpendicular, it works out nicely that way. The current is 3. The length of the wire is given as 2 meters. I'm leaving the units off because I've checked them and they're all right. But we want to make sure we have units at the end, of course, but sometimes it's okay to cut corners in doing the work if we have checked the units at the beginning and we know that they are correct. The magnetic field is 6. What do we get when we put all that together? I'm seeing a 1/2 and a 2. Those cancel each other out, and so it looks to me like we're going to get a total torque of 18 Newton meters. 3 times 6. And which way is the force on this side? Shall we do that? That portion right there. In what direction is that magnetic force acting? The current on that side is going toward the bottom of the page. And if the current is going to the bottom of the page and you use the pat-pat right-hand rule and your fingers are pointing in the direction of the magnetic field, then that force is going to be directed up like that. And what about the force on this rightmost portion? Again, we're going to use our right-hand rule, and we're going to say that the current in the rightmost portion is going toward the top of the page. The fingers point in the direction of the field. Sure enough, there will be a torque on this loop. And won't the torque from the right be identical to the torque on the left? So I think the total torque is going to be 18 plus 18, which is 36 Newton.